45. Is there anyone who's still outside? 1, 2, 3, 4, 5, 6, 7. Satu lagi siapa ya? Yang belum hadir, Bu Triana?
Hanya bertujuh, Bu.
Sudah semua ya?
Iya, sudah semua.
Yeah. All right. I think the students already here now, and also Bu Herani. Bu Herani, apakah kita mulai sekarang?
Ya, silakan.
Bisa mulai ya? Oke. Oh ya, Bu Herani, sebelumnya untuk pekan depan mungkin bisa dibantu. Bu Tri ikut LSP juga nggak? Ikut ya?
Iya, Ibu.
Oke. Ya, nanti mungkin gimana teknisnya nanti kita bisa diskusi lagi ya. Oke, mungkin kita mulai saja, Dr. Magis ya. Bismillahirrahmanirrahim. So, good morning everyone. Today we're going to have a lecture with Associate Professor Dr. Magis from USM. And today's discussion will be about continuing data analysis in quantitative research study as well as the instrumentation, yeah, Dr. Magis, for today's discussion. Hopefully, we can cover them all. And what about the problem statement? I think if we still have some time to discuss about it, maybe we can go through it, yeah, Dr. Magis, yeah.
So maybe we can. Actually, that's why I have actually gone through the problem statement. Can you hear me, Dr. Suzy?
Yes.
Yeah, okay. Good morning, everyone. I hope you are prepared, and Dr. Hernani also is there, I suppose. Yeah, selamat pagi. Okay,
Pagi, Bu.
Right. So before I start the lecture, let me just say something about the problem statement. Firstly, yang dibagi kepada saya, it's more like a research question than a problem statement. It reflects as though it's a research question. Let me share with you that PowerPoint first. Maybe it can give you a, hold on. Share the screen. I got. Okay, hold on, please. Switch off this one. Yeah, can you see the problem statement now?
Yes.
Yeah. Right. So I have gone through the problem statement. So the first thing is this one looks more like a research question rather than problem statement. So if you want me to go detail about the problem statement, maybe you need to write more, explaining about what actually you want to investigate. Hold on, why my video not on? You can't see my video, right?
Yes, Doctor.
Oh, okay, right. So come back to the today's this one. So like for example, this one. Bagaimana perkembangan media pembelajaran kimia berbasis game dalam meningkatkan hasil belajar mahasiswa pada mastery stereoisomer. So from here, what I can see is it's more like a research question. So I can understand that the student, he or she wants to use pembelajaran berasaskan permainan game dalam meningkatkan pemahaman stereoisomer. I can understand that. But how the research going to be done, how the student plan to do the research, I am not sure because there's no information here. So if you ask me whether the research is the question is researchable or not, yes, of course the question is researchable. So it can be conducted. Whether the problem is justified or not, I'm not sure because there is no details on it. Okay, so looking at this question, it looks like a more on a qualitative study because you're using the word bagaimana. Bagaimana is a verb you are going to explore.
Mhm.
You know, so ini adalah lebih kepada satu kajian kualitatif. You know, so you are going to explore how pembelajaran kimia berasaskan permainan game boleh meningkatkan mastery stereoisomer. So if you ask me, can be done or not? Yes, of course can be done. But how you're going to do, I'm not sure because there's no details. Whether it is justified or not, I'm not sure as well because you never give me a complete problem statement. Like if you look back my lecture, I have given 5 steps in writing problem statement. So if you can write according to the 5 steps, then I can justify. I mean, I can give some feedback whether it is appropriate or not appropriate. In terms of whether can be done or not, yes, of course can be done. Okay, same thing. The second question, bagaimana? So you're using the question bagaimana. Bagaimana means is qualitative. So I'm not sure the student really intend to do qualitative or they just simply said bagaimana. So now same like the earlier research question, pembelajaran berasaskan 3 level, 3 level representation in chemistry dengan model POE. So you are using the model POE model which is based on 3 level of representation dalam meningkatkan mastery terhadap reaksi dan catalyst. Okay, no problem, can be done. But it's a qualitative research because you are using bagaimana. You know, so this question maybe boleh pecahkan lagi jadi smaller questions so the research will be clearer. Okay, so again, this is how is the effectiveness of Johnston triangle schematic to design pre-class videos in quiz classroom. So this one is more like a designing the treatment. So this is researchable. This is researchable. But this question, I'm thinking the student is having some problem because the student is saying how is the effectiveness of Johnston triangle schematic to design. So is the student going to design the lesson is the student going to design the lesson using videos in ataupun flip classroom lah. So it's not very clear whether he going to design the lesson then measure the effectiveness or he is measuring the effectiveness of Johnston triangle. So this question is not clear. So maybe the student should say that what is the effectiveness of flipped classroom designed based on Johnston triangle schematic. You know, what is the effectiveness of flipped classroom? Flipped classroom means we know already it's a video plus some teaching. So flipped classroom designed based on Johnston triangle triangle in improving hydrocarbon materials. So this one needs some changes, right? Now, this one also no problem, can be done. Bagaimana konsepsi trouble some knowledge threshold concept berdasarkan pengaruh terhadap. This is okay. This is no problem, can be done. Now, bagaimana pengaruh penerapan instrumen penilaian kerja terhadap this one also is tak berapa jelas, you know, tak berapa jelas. Bagaimana pengaruh penerapan instrumen penilaian kerja terhadap kemampuan berfikir sains, penguasaan konsep asas pada praktikum penentuan. So actually I cannot understand what the student trying to say here. Maybe he or she need to rewrite apa yang sebenarnya dia nak buat. Bagaimana pengaruh penerapan instrumen? Adakah kamu nak terap instrumen penilaian kerja terhadap ataupun so the IV here is penerapan instrumen penilaian kerja. Bolehkah instrumen diterap? This one like not so clear. Maybe perlu diperhalusi lagi. Terhadap kemampuan berfikir sains, okay. Penguasaan konsep asas, okay. pada praktikum penentuan kadar. I think this part not very clear. Mungkin kita perlu berhalusi lagi lah, yang ini. Okay. Apa yang student ni nak buat? Saya boleh faham yang dia nak ukur DV dia, pemikiran sains, penguasaan konsep asas, ini saya faham, dan benda ni akan dilakukan semasa praktikum pada tajuk kadar, yang ini saya faham, tapi yang ni tak berapa. Bolehkah instrumen diterap atau apa maksud instrumen di sini? Instrumen ini adakah satu proses pengajaran dan pembelajaran ataupun apa dia? Okay, yang ni. So dia kena jelaskan lagi. Okay, right. So bagaimana pengaruh model pembelajaran Simayang terhadap miskonsepsi? So yang ini pun kualitatif, saya pun tak pasti sama ada pelajar memang nak bertujuan nak buat kualitatif ataupun dia silap, dia tak berapa faham apa nak buat, dia tulis soalan macam ni. So mungkin kalau dia tukar jadi apakah ataupun
apakah model pembelajaran Simayang pengaruh gitu?
Ya. So apakah keberkesanan model pembelajaran Simayang dalam meningkatkan atau menurunkan miskonsepsi ikatan kimia? Okay, so bagaimana tu saya nak tahu, adakah soal pelajar nak buat kualitatif? Memang itu tujuan mereka. Kualitatif.
Kuantitatif, I see.
Okay, so kalau begitu soalan ni dah bagaimana ni sudah tidak betul. Okay, right. So kalau tukar ke kuantitatif dia akan jadi apakah keberkesanan pengaruh model pembelajaran Simayang terhadap miskonsepsi siswa pada masteri ikatan kimia? Right. Okay. Right. Mengembangkan, memainkan dalam yang ini pun kurang jelas. Mengembangkan dan memainkan game kimia dalam meningkatkan apa maksud mengembangkan? Mengembangkan maksudnya dia nak buat disseminate, dia nak perkataan mengembangkan ini tidak sesuai digunakan untuk persoalan kajian. Ataupun yang ini kita boleh sebut sebagai tajuk kajian. Okay, mengembangkan dan memainkan game kimia dalam meningkatkan pemahaman kimia. Masih lagi saya tidak setuju dengan penggunaan perkataan ini. Mengembangkan dan memainkan. Macam dia, kalau dari segi saintifiknya, perkataan ini mengembangkan dan memainkan ini nak gunakan pada tajuk, saya rasa tidak begitu sesuai. Mungkin apa yang boleh dibuat, cadangan saya, mereka bentuk game kimia. Okay, mereka bentuk game kimia dan menentukan keberkesanan dalam meningkatkan pemahaman konsep kimia unsur. Something like that. Okay, boleh tak? So yang serba sedikit lah. So kalau nak detail, saya cadang cuba tulis problem statement ikut 5 peringkat tu. So I can give you more detail information whether you are doing the right thing. Okay, boleh ya? Right. So let me go to the next today's lesson. So ada apa-apa soalan nak tanya tentang problem statement ni before I go to the today's lesson? Any of you want to ask me anything?
Oke, bagaimana? Ada pertanyaan? Tadi kita kembalikan lagi ke tahapan-tahapan pembuatan problem statement yang ada 5 tahap, ya. Kita ikuti lagi itu. Dan tadi catatan-catatan dari Dr. Magis tolong diperhatikan, ya. Jadi mesti seperti apa perbaikan ke depan. Okay, this is the raw one, Dr. Mages. I just want opportunity to discuss it with you from the raw one. But later on, perbaikannya kita diskusikan dulu dan after itu baru kita coba konsultasikan lagi ke Dr. Mages.
Okay.
Terima kasih, Dr. So
Thank
I think
you.
we can move to the next topic, ya.
Okay, right. Hold on. I hope you will bear with me. So I will be shifting with a few things. Sebab ada Word file I want to show as well as PowerPoint. So I'm not sure whether this will be an easy task or not. Because as I told you, I'm not so used to Zoom. If WebEx, yes, I know how to go about it, but it's okay. We will try. Okay, so today's lecture will be on multivariate data analysis. So last week, we talked about univariate. Okay, minggu lepas we talked about univariate. So in the univariate analysis, I did mention about t-test. I did mention about ANOVA. I touched on repeated measure design, and I touched on ANCOVA. Right? So all these are univariate analysis. Okay, why we call it univariate? Because our DV are normally is like the DV is usually 1. 1. So like ANOVA, when you use ANOVA, you are comparing two means. So you have your let's say female and male. They are two different groups, and you are comparing the means. Let's say you are comparing what do you call that, location of school, rural, urban, semi-urban, semi-rural. These are categories of school, and you are measuring with the achievement. So we can actually break the IV into categorical. We call it categorical data. Categorical data, that means you have several categories. Female is one category, male is another category. Location of school, rural is one category, urban is one category, semi-urban another category, rural another category. So you have 4 categories of data. And then if you look into socio-economic of the parents' income and all that, you can say, okay, 1,000 to 2,000 is one category, or 1,000 to 5,000 is one category, 6,000 to 10,000 another category, and then 11,000 to 15,000 is another category. So I'm talking about the income. So you categorize them into the categories. So this one we call it as categorical data. So for ANOVA, when you want to use measure using ANOVA, you have categorical data, and you are looking into the effect on the DV. This is what I have said last week. Hope you can recall back. Lepas tu, I talked about ANCOVA. ANCOVA is similar to ANOVA. Only thing is you controlling the covariate. Okay, covariate. So covariate ini, so for example, your pre-test. Sometimes when you want to compare the experimental group and control group, or you want to compare gender, you need to control some other variables that might affect the finding. Okay, so for example, pre-test. If you don't control the pre-test, what will happen is the pre-test will create an the finding that you got the post-test finding, you cannot 100% sure, you cannot rule out it is actually caused by the treatment. Maybe the pre-test would have some impact or some effect on the finding of the post-test. So in order to control that, we control the pre-test result. So controlling pre-test is what we mentioned, what we say in the statistical analysis is controlling covariate. So pre-test is one of the covariate that you can actually control before you conduct your ANCOVA analysis. So Similarly, let's say you want to find the gender effect. So there might be some other thing that might affect. For example, socioeconomic status. You only want to see the effect of gender, but then the socioeconomic status uh, uh, combined with gender, and that affects the outcome in the post test. So you might want to control the socioeconomic status. So socioeconomic status become the covariate. Okay, so these are some examples. So if you ask me what are covariates, covariates are some variables. If you don't control them, it will affect the findings. It will affect the post-test finding, the outcome, the DV. Boleh faham? Huh? Okay, so for the experimental design, the covariate biasanya usually is pre-test. You know, so for other designs, it depends. Like if you want to like measure effect of gender, how gender affects students, how gender affects students participation in ICT, for example. Okay, students participation in ICT. So you want to know whether male or boys boys participate more in ICT or girls participate more in ICT. But then it's not only about gender. Parents' income also another issue, because if parents can afford to buy computer, they have laptops in their house, they have iPads in the house, then the students will participate. It doesn't matter whether it's girls or boys. You know, so parents' income is also another reason which can combine with gender and create whether they participate in ICT or not. Okay, so in order to find the gender effect, what we need to do is to control the socioeconomic status of the parents. You know, so that's where ANCOVA plays a role. And then last week I ended with repeated measure ANOVA, right? So pre-test, post-test 1, post-test 2, then you compare the 3 means. So what we call it as, we call the analysis as repeated measure ANOVA. So you have a in the SPSS, you can actually there is a icon there is a icon for you to click and then do the repeated measure ANOVA. So basically the what you call that, the reason for using repeated measure ANOVA is we want to make sure when the treatment is consistently, students are consistently exposed to the treatment, how it affects the outcome. So that's why we have time 1, we have time 2, we have time 3. So you can have how many times that you want to. Okay, so that is repeated measure. So along all this, anything?
Dr. I do apologize to interrupt. In my screen, the screen is still in multivariate data analysis. Is that?
Yes. Because
Okay.
I'm just revising the last week's
Yeah.
one. I haven't gone to here. Okay.
Okay.
Right.
And can I have one question regarding the covariate?
Yeah.
Yeah. You've mentioned that we have to control the covariate, otherwise it will be influence the result. Yeah.
Yeah.
For example, the pretest. Jadi how to control the pretest? Is that by only involving the students with the same or with the homogeneous result of pretest? Is that the meaning of how controlling the pretest, and how to controlling parents' income? Is that by selecting the students with the homogeneous parents' income? Not very, yeah.
Yeah, that is our effort as a researcher. So you control, you make sure that you are getting this. That's why we do the pre-test comparison mean. So group, control group and experimental group, we compare the mean, whether it is significant or not significant. That is, as a researcher, that's our effort. And also what you mentioned just now is like socioeconomic status. We try to get the students from same parents with same that is, as a researcher, that is our effort. But sometimes it goes beyond that. Okay, you still collect the data on the socioeconomic status, you still collect the data on the pre-test, but when you put it in the SPSS data analysis, when you want to do the ANCOVA analysis, the system itself will ask you, what is your covariate?
Okay.
So you can bring your pre-test as a covariate. You can bring your socioeconomic status as a covariate. So once you key in as a covariate, you can, once you present it as a the data as covariate, so SPSS will catch it as a covariate. When the analysis is performed, it is the covariates are controlled.
Okay.
You know, yeah. So that is the statistical analysis part, the SPSS part. You know, so you still collect pre-test result, you still collect socioeconomic status or whatever data you want to collect, you just key in the SPSS. In the SPSS, when you want to run the ANCOVA analysis, the system will ask you, what is your covariate? So you just mention, okay, my covariate are pre-test. So you just click drag and drop it in the covariate box. Or you can drag the socioeconomic status and drop it in the covariate box. Okay, so that is ANCOVA. Okay, right. So if I want to go to the SPSS part, then I need more time. I don't think I have the time here. So actually that is very easy. You just go to YouTube, you just type in step by step to perform one-way repeated measure ANOVA. You will get it. So same thing, ANOVA also step by step to perform one-way ANOVA or two-way ANOVAs, you know, something like that. So that part is like you just follow procedure. It's not a big thing. But in order for you to do that kind of step, you need to understand why you want to do that, the philosophy behind it. Okay, so in the analysis that I mentioned last week, the entire univariate analysis that I mentioned last week solely focus on the dV is mostly is one dV. I don't think I have mentioned anything with more than 1 dV. So if you talk about ANOVA, you are looking into achievement, you are comparing female and male, two groups. Achievement, class 1 and class 2. Achievement, student from level 1 and level 2. So the ANOVA is categorical, the IV is categorical, but the dV is still the same. Okay, now today we are expanding from ANOVA or univariate analysis to the multivariate analysis. So multivariate analysis is actually, you are expanding ANOVA. You know, you are actually expanding ANOVA. So in the ANOVA is univariate, one variant, but one variant, one variable. But when you go to MANOVA, multivariate analysis of variance, you are going into multiple variable. Okay, so like as I mentioned just now, when you use one way MANOVA, you are using one independent group, one independent variable. Okay, one independent variable. So you have to get it very clearly. Until if you don't get it, you will get confused. One independent variable, IV dia satu saja, but that IV will have groups. Okay, that means female, male, level of student, high level, mediocre, poor, socioeconomic status, high income, low income, medium income, rural, urban, semi-urban, or apa-apa. So IV is only one, but that IV you have many categories. Same like ANOVA. IV is only one, gender. You have female, male, socioeconomic status, high income, low income. So IV is only one, but you have many categories. But your dependent variable, and these IVs are categorical data, and your dependent variable, you will have more, two or more dependent variables. So this is called And these dependent variables are continuous variable. So it is measured on continuous scale. So for example, you want to measure understanding in rate of reaction, for example. But rate of reaction, you have many factors. The how size influence the rate, how temperature influence the rate, how presence of catalyst influence the rate. Apa lagi ya? What else? So let's say we have three here. Okay, size, presence of catalyst, and temperature. So rate of reaction is the big topic, right? In order for you to measure how student understand rate of reaction, you have the subscales there. So first is the students must know how size of substance influence the rate. The second is how temperature of the solution influence the rate of reaction, and then how presence of catalyst influence the rate of reaction. So that means they need to know these three subtopics in order for them to understand the overall rate of reaction. So here the three subtopics are the dependent variables. So these three subtopics are continuous dependent variable. How you measure the understanding? You measure the understanding from 0 to 10. So you give 10 questions where how many answers they got it correct. Or you can measure in terms of percentage, 0 to 100. Okay, that is one example. Okay, other examples could be you want to measure the attitude. Okay, in the attitude you got many subscale. Like you take if you, for example, new ecological paradigm. Okay, that is attitude questionnaire. In that attitude questionnaire, you got 5 subscale. So you want to measure the 5 subscales, right? So each subscale got 4 items. I hope all of you can follow. Boleh ikut, That's why I'm going quite slow. I don't want to rush into it. You might get confused. So each subscale got 5 items. So in order to measure the attitude overall, you need to consider all the 5 subscales of attitude. So that 5 subscales are known as continuous dependent variable. Continuous scales because it is measured from you are using Likert scale 1 to 5 or 1 to 7 or something like that. So you must be very clear now. ANOVA is one dependent variable. The independent variable, it has groups. MANOVA is different than ANOVA because it has one dependent variable. One independent variable, but it has many dependent variable, or two or more continuous dependent variable. So we can say that if you really understand what I'm saying, you will know that you will realize that MANOVA is only an extension of one-way ANOVA. Okay, MANOVA is the extension of one-way MANOVA. Okay, like so. For example, here, anxiety level, we have 3 groups: low stress student, moderately stressed student, highly stressed student. And then the DV, there is 2 DVs here: maths and English performance. Can you see? If I'm using ANOVA, I only will measure maths exam. I won't look into English exam. So the DV is only 1. But here I'm having 3 category, 3 groups. The DVs are the IV is single IV, but that single IV is presented in 3 categorical groups. And then my DV is maths exam. And this maths exam might have maths and English exam because there is a 2 DVs here. Okay, boleh, right. Another example is gender. So I'm looking into gender, female. Gender is the IV, but then we are having 2 groups. Same like ANOVA, but the DV, I'm having, you see, liking for chemistry lesson, theory, liking for chemistry laboratory, evaluative belief, behavioral tendency. So the attitude, it has 4 separate subscales or 4 separate elements. You know, so it's not attitude as one attitude, but that attitude is separated into 4. Each liking for chemistry got a mean value. Liking for chemistry lab got a mean value. Evaluative belief, there is a mean value. Behavioral tendency, there is a mean value. So in total, there is 1, 2, 3, 4. 4 means that you need to compare. Compared to ANOVA, you just talk about attitude overall. Okay, I hope you understand now. Now, I want to go more deeper. So this is called one-way ANOVA. All the while, whatever I've mentioned is one-way ANOVA. Okay, we have grade level, we have Form 4, Form 5, Form 6, Upper 6. So these are different grade level. But the IV is only one grade level. The only difference is IV is categorized into 4 groups. Okay, 4 groups. So the DV is attitude towards chemistry. Boleh? Right. Now, teaching experience. Okay, teaching experience. Teaching experience levels. So 1 to 5 years, I group as category 1. 6 to 10 years, category 2. 11 to 15 years, category 3. 16 to 20 years, category 4. So these are categorical. Then I want to see how it improves the STEM teaching efficacy. So STEM teaching efficacy got 1, 2, 3, 4, 5. 5 subscale. Instructional efficacy, classroom management efficacy, student engagement efficacy. What is CI? I forgot already. This is open-endedness efficacy. Okay, so there are 5 efficacy. So you see the DV got 1, 2, 3, 5 means. So each instructional efficacy got a mean. Classroom management, there is a mean value there. Student engagement, there is a mean value there. Open-endedness, there is a mean value there. So you want to see how the 4 levels of teaching experience affects the DV, which is STEM efficacy. If you use ANOVA, you won't have all these things. You won't have all these things. You will only have STEM self-efficacy, STEM teaching efficacy. That's all overall. Okay, right. Now, then you have locations of school, rural, urban, and then you want to see how it affects the STEM teaching efficacy. So all these things is called one-way ANOVA. Okay, one-way ANOVA. Right. Any question on one-way ANOVA? Sorry, one-way MANOVA before I go to two-way MANOVA. You have to be very clear because later I will show you analysis. At that time, if you don't understand the first part, probably you will be lost in the second part. Okay, right. So if you have a question, you can ask me. You can stop me and ask. Right. Now you see here, STEM efficacy, there is 5 subscale. Then we looked into what is the effects of teaching experience, years of teaching experience, and how it affects the DV. Then after that, this is one-way MANOVA. After that, we looked into the location of schools, rural and urban, and how it affects efficacy. So now if you look at the IV, we have 2 IVs. One is years of teaching experience. Another one is location of school. So based on literature and also my finding shows that, if the teacher's teaching experience is large, is huge, the efficacy of their teaching also better. My finding shows. Then I run another time of MANOVA. I see, okay, rural urban teachers. Which teacher, which group of teacher have higher efficacy? I realized that, urban teachers' efficacy level is generally higher than the rural teacher. But then, some studies shows that combination of the teacher with the higher experience from the urban school do not actually high efficacy. Rural teacher from the teacher from rural schools with less teaching years exhibiting higher efficacy. So you see, my hypothesis is, when I conducted one-way MANOVA, my first hypothesis is there is no significant effects of location of school on the teacher's STEM teaching efficacy. Then from finding, I reject the hypothesis because my finding shows that location of school actually affects the teaching efficacy. So I rejected my null hypothesis. Then when I conducted teaching years of experience, then I measure the efficacy. The null hypothesis that I've stated is there is no significant effects of years of teaching experience on STEM teaching efficacy. But my finding shows there is a significant there is a significant mean difference, so I reject the hypothesis. But when I combine rural and teaching experience, looks like both the location of the school and teaching experience collectively combined, and that affects the teaching efficacy. So do you think it's appropriate for me to do one-way MANOVA, checking the location of school separately and checking the teaching experience separately? Do you think it is appropriate? No, right? So what I need to do is I need to combine both together. So now the finding that I got using one-way MANOVA, actually I go and reject the null hypothesis. What I did is I did type 1 error. In my analysis, there is a type 1 error because by right, I should not reject the hypothesis. There is no significant difference. By right, I should have accepted the hypothesis. Because location of schools and teaching experience, you cannot measure separately. It is incorrect. It is not justified, or it is statistically, I mean, in terms of how to mention this, the way you conduct this analysis is correct. Statistically, when you conduct the analysis, you perform MANOVA, you perform step-by-step MANOVA, it's correct. But from the research perspective, it is incorrect to do one-way MANOVA for analyze the location of school and analyze years of experience separately from the research perspective, because research says that location of school and years of experience, they work together, they combine. The effect is collective effect. It is not a single effect or separate effect. But in the analysis, you go and did the separate analysis. So probably opting for one-way MANOVA is not appropriate. So the best way to do this research is to do two-way MANOVA. So when you do two-way MANOVA, you see you're having teaching experience, you're having location of school. So teaching experience is one IV, location of your school is another IV. So you are having two IVs here. And then you are measuring the effects of the IVs on the DVs. The DVs are still same. They are instructional efficacy, classroom management, student engagement, community involvement, and outcome expectancy. Do you all understand? Can you all follow? Right. So you are combining two-way, you are doing two-way MANOVA because rather than doing 2 times one-way maneuver separately, which you can create. The possibilities of creating type 1 and type 2 errors are huge. But when you combine them together, you will be, the possibilities of avoiding type 1 and type 2 errors are there. Understand? Right. So similarly here, I just want to go back to here. Now, you see female, gender. You want this study, actually I can share one of my paper published. I can share the paper with you later. Right. You see gender, female and male. I can actually do one-way maneuver and see what is the effect of gender. But then, effect of gender doesn't happen as a, I mean, the how to say it? Okay, female at the higher level, higher grades or higher level of education, actually they liked to learn chemistry. But then the female student at the lower level, maybe they are just beginning to learn chemistry, maybe when they are 15 or 16 years old, they dislike chemistry. They don't want to learn chemistry, you know. But female student at the undergraduate level or at the pre-university level, they like to learn chemistry. So if I simply say there is no significant effects of female, that means female doesn't like to learn chemistry, the statement I'm making is wrong, because it's not matter of male or female. It is matter of male or female in combination with grade level. You know, so here grade level, here form 4, form 5, lower 6, upper 6. So this is our secondary education. Lower 6 and upper 6 is our pre-university level. So I cannot say that upper secondary school students, they like to learn chemistry, they have a good attitude for chemistry, because the higher education, the upper secondary schools, upper form 6 students, male seems to like chemistry more, but females do not really like chemistry. So I cannot simply say all the upper form 6 students, they like chemistry. So it's incorrect. So I'm creating type 1 and type 2 errors. So the best way to solve this problem is to conduct two-way maneuver. So that means I analyze both grade level and gender together, and I look into how it affects the DV. So that is called two-way maneuver. So I'll share this paper with you. So nanti you all can read the paper and try to understand what I have done. Okay, so let me go a bit deeper on the analysis part on one-way maneuver. So if you want to stop me, you can just stop me. Right. Now, so one-way maneuver and two-way maneuver, they are roughly, the way to do the analysis is same. You just have to understand the philosophy behind it. Once you understand the philosophy behind it, doing it will be easier. Okay. So now I'm going to stop the sharing and I'm going to open my Word file to show how we can go about it. Okay. Give me a second. Oh, okay. Hold on. Hold on. Hold on. Right. Okay, before I go to that, let me talk to you about the assumption first. Hold on, hold on. Okay, let me talk to you about the go through the things first before I go to the analysis part. Okay, so just now I mentioned about two-way maneuver. Okay, this is one way, one kind of analysis. The next is repeated measure maneuver. So repeated measure maneuver is same like repeated measure ANOVA. ANOVA, you have pre-test, post-test 1 and post-test 2, right? So in this case, you still have pre-test, post-test 1 and post-test 2. Only thing is now your DV, you have many category. You have like in this case, for example, that I want to use is I measured critical thinking skills of the student. So how green chemistry affects critical thinking skills of the students. So the critical thinking skill is there are three what you call that, there are three subscales. Okay, there are three subscales: recognizing assumption, evaluate arguments, draw conclusion. So this is a three subscales of critical thinking skill. So the DV is recognizing assumption, evaluate arguments, and draw conclusion. So if you recall back, repeated measure ANOVA, last week I mentioned it's only one group. What is repeated is the time 1, time 2, time 3. Okay, so in this case it is still similar. What is repeated is the time 1, time 2, time 3. But last week the DV is only one, achievement or something like that. But in this case DV is 3: recognize assumption, evaluate arguments, and draw conclusion. Okay, so I will talk about how it matters in writing the repeated hypothesis in a short while. So if I tell you now, probably you might not understand. Okay, right. I just want to tell you there's something called repeated measure maneuver. Okay. Now, so in order for us to conduct one-way maneuver, two-way maneuver, or repeated measure maneuver, the first step is to check the assumption. Okay, before I can show the analysis, I want to explain what is assumption. Okay, so there are few assumptions that you need to check. The first assumption is the independence. That means the IV are independent. That means when I talk to you about location of school and years of experience, these two IVs are not what you call that, you must make sure when you measure the two IVs, there is no interaction between the IVs. Say they are totally separated. So you must make sure that there is no interaction between the IVs. So dilution does not take place. So independence here is the IVs are as separate as possible. So this is in your hand. As a researcher, you must make sure that there's no interaction or there's no dilution, there's no any kind of overlap between the independence variable. Okay. Now the second assumption is equality of variance covariance matrix. So if you still remember last week when I mentioned about ANOVA, you want to make sure homogeneity of variance. I did mention last week. So the same thing here. So the equality of variance or homogeneity of variance are the same. They are same, only the words are different. But what are you measuring is the differences in the amounts of variance. You know what's variance? I mentioned last week, variance is the spread, right? The spreads. Variance is the spread in the data. If you have a bell curve, the spread in the data is variance. So equality of variance, that means differences in the amount of variance. Okay, yeah, differences in the amount of variance. So you want to make sure that the differences are equal. Okay, the differences are equal. So what we did for ANOVA last week, we measure the variances using leave-in tests. I did mention that we measure the variances using leave-in tests for ANOVA and t-test. right? So in this case, for MANOVA, we will be using t-test, we will be using leave-in test, as well as we will be using box M. Okay, so what you need to know is, before you can conduct MANOVA, multivariate analysis, you need to check for assumptions, whether your data meet the assumptions or not. The first assumption is independence. The meaning of independence is you must make sure the two IVs, MANOVA, now we have two groups, right? Two IVs, right? There is no interaction between the IVs. The IVs are separated as much as possible. That one, as a researcher, you can do it. The second assumption is equality of variance. So last week I mentioned about homogeneity, right? So equality of variance, that means we want to check the differences in the spread. What is spread means? There's a bell curve. You know, we can draw a bell curve in the using the data that we obtain, the DVs. Then you can see how is the spread. Is it skewed to the right, or it is skewed to the left, or it is normal distribution? You know, so we need to check whether the differences in the variance. Now we have many DVs, right? The DVs are equal or not equal. Okay, so for this, what we need to do is we need to do leave-in test. And also we need to do box M. Okay, and once you check the equality of variance, we check for the normality of the data. Okay, so this is for the DVs. Okay, this is for the DVs. So we check the equality of variance for ANOVA, which is leave-in test, MANOVA, which is box M, and we will check the normality. And then the third one is linearity and multicollinearity among dependent variables. So we want to make sure that there are many DVs, right? Like for example, I showed 5 DVs for the self-efficacy, 4 DVs for the attitude. We must make sure that there is no interaction effect. There is no non-linear relationship. The relationship between the DVs are always linear. So we must check for that as well. So before we can conduct one-way MANOVA, two-way MANOVA, repeated measure MANOVA, this is the assumptions that we need to meet. Okay. So what is the assumption? As I said, first is what do you call that? Independence of the IVs. Second is equality of the variance of the DVs, and linearity and multicollinearity of the dependent variables. So it says that we must make sure there is non-linear relationship between the dependent variables. Okay, non-linear relationship between the dependent variable. So here is IV. The first assumption is for IV. The second assumption is for the DV, and then the third assumption is also for the DV. Later, I will show you how we're going to go about it. Okay, now let's see how we can go about it. Now, let me show you one example. So I have to stop sharing now. I'm not sure which one you're seeing. Can you see the word multivariate normality here? Are you seeing that?
Yes,
Okay. Right. So now I'm going to show you how to do one-way MANOVA and two-way MANOVAs. Okay, I'm going to merge them together. Okay. Now, as I said, before we can conduct multivariate analysis or any univariate analysis, the first thing is we must check for assumption. The first assumption is I told you the independence variables, they should be independent. That one you can justify how you conducted the data, so how you ensure that they are separated. You know, there is no what you call a dilution there. The second is I said you must find the homogeneity of variance or equality of variance. So for that you need to do leave-in test as well as box M. So I will show you now. When you run the data, this is how you will get your box M result. So from here we get the box M, the results as non-significant. So 0.183. This is more than 0.05. Okay, this is non-significant. Now from here you can say that how to say, from here you can say that the variances, okay, the variances uh, 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 in the DV is equal. That means we can assume the variances are equal. There is no significant differences in the variances. Okay, now then I go into the leave-in test. The leave-in test, I go very specific into each DVs. Hope you can follow. I mentioned 5 level of efficacy, right? The DVs. Now you can see the significant here. All these are non-significant. Okay, so from this non-significant, I can say that the variances among all these subscales of DVs are non-significant. So that means the variances are equal. Okay, so the hypothesis we have made, or there is a standard hypothesis for assumptions, there is no significant differences between the variances, you know, significant difference in the variance. So we can see that all these are non-significant. So we can reject the hypothesis and we can say that the variances are equal. Can you understand? So that means the data that we have, that the data I have meet the assumption the variances are equal. So this is for the overall variance of considering the entire DV, okay, box M, and this is for each subscale, and you can see it is all significant. Okay, right. So I can tell you that the first assumption is met. The first assumption, whether the independence of the IVs are there, I can ensure they are independent because I'm going to explain how I collected the data. I ensure there's no interaction. Then I did the box M and I did the leave-in test. So both the test shows that the homogeneity of variance covariant matrix. So the variances are equal. The next, I'm going to check into the multicollinearity. So multicollinearity, I just want to make sure that there is no non-linear relationship between the DVs. So I have DVs here, IS, EM, SE, CI, OE. All these are 5 DVs, and then I'm getting the interaction is all non-significant. You can see all non-significant. So that means the relationship between the IVs are linear. You know, the relationship between the IVs are linear. So once I meet all these assumption, then only I can conduct MANOVA. So in conducting MANOVA, checking assumption is very, very important. Okay, then I did the what you call that normality test. Normality test, I don't know whether I have put it here or not. Yeah, this is the normality test. Normality Kolmogorov-Sinov or Shapiro-Wilk. Okay, this is the normality test. So normality test, we get to know whether the data is evenly distributed. And I also checked for outliers. If there is any outliers, I also want to take it out. So there is no outliers. Looks like Okay, the box plot says there's no outliers. So if you see here, we check for the normality for the DVs. There is no outliers for DVs, and I checked for the box M, whereby the overall the variances are equal, and also I did for separately for each subscales of DV, and it's also the variances are equal. And then I checked multicollinearity. Multicollinearity shows that the relationship, all these are shows that the relationship between them are linear. Okay, right. So now I have met all the assumptions. Now I can conduct one-way maneuver or two-way maneuver. So do you all understand? Do you have any question before I can go into the maneuver? So what I've talked to you so far is only meeting assumption. We must meet all the assumptions before we can start with the maneuver, real maneuver.
Excuse me, Dr. Mages.
Yeah.
Yeah, can I ask you about the table about multicollinearity?
Okay. Yeah. Right.
Okay. Between in this table, which number or which data actually that we can refer to say that there is no multicollinearity?
Okay. Now you see, IS is one variable, right?
Yes.
Actually, all this is repetition. So here you see the relationship with IS and CM.
Okay.
IS and SE. So instructional efficacy and classroom management. IS and
Student
SE.
engagement, yes.
Yeah, IS and CI and IS and OE.
Mm.
So actually referring to this table, this data is good enough already. The others is repeating.
Okay.
CM and IS. So if you see this one, this finding is equal to something, this one, right?
Oh,
This
yeah.
overlap.
Yes,
And
yes.
this one is this one.
Okay.
CI is here. So when you run the correlations analysis, this is how you will get. That's why you see 1, 1, 1, 1, 1. Because this one you're measuring IS and IS1.
Okay.
CM and CM1. So actually you refer to this. The first one is good enough already. All the findings are there.
Okay. Thank you, Dr. Mages.
Right. Okay. Yeah. So far what I've said is just meeting the assumption. So after meeting the assumption, now we are going to the maneuver. Okay. So usually what we will do in the analysis, we will try to find the descriptive statistic first. So descriptive is like mean and standard deviation. So IS, instructional efficacy with the teachers with 1 to 5 years experience, and school location, rural, urban, this is the mean. Okay, so the data that I'm showing now is two-way MANOVA's data. Actually, if you run one-way MANOVA, you will just get this part. If you are running on a teacher's experience, years of experience. If you run with the school location, you will only get this part. So since I'm doing two-way MANOVA, I'm getting both. Can you follow? So it's exactly the same. If I do one-way MANOVA, I will only get this part. You know, because I'm doing both together, I'm getting the years of experience, location, and the mean. So I'm getting 1 to 5 years experience teachers from urban school, the mean is such. 1 to 5 years teachers from rural school, the mean is such, something like that. Actually, so N is here is actually frequency. How many teachers I have? 23 for urban and 28 for rural. You know, so I should have included one more frequency that will give a better picture. So I overlooked on that. Okay. So I hope you can understand, follow me. So this is descriptive statistic. So CM, what is the descriptive? So nothing much here, descriptive. I hope you understand what is descriptive. Now we go into multivariate. So now you're getting the MANOVA result. Okay. So the MANOVA result, the first is, you see, let's say you're running one-way MANOVA. Okay, you're running one-way MANOVA with teachers' year experience. So you will only get this finding. Okay, you will get only this finding. Then usually we will look at Wicks lambda. Don't ask me why Wicks lambda, because the literature says so. We look at Wicks lambda. Then you see there is a significant effects of teachers years of experience on self-efficacy. So this is overall multivariate. We are not looking into the each scales. We are getting the overall picture. Okay, now school location, we look at the Wicks lambda, also significant. There is significant effects of school location on teachers' self-efficacy. So actually speaking, this is how to say, I would say this is ANOVA, one ANOVA, this is another ANOVA. Okay, this is one ANOVA, this is another ANOVA. Because we are not looking into the subscale here yet. We are just looking into the teacher's years of experience, and you are looking into whether there's any significant or not. School location, and other there's a significant or not. Okay, right. When you combine both teaching experience and school location, the combination of teaching experience and school location, now we look at the Wicks lambda. It is 0.17. It is also significant. So teaching experience separately, there is a significant effects of teaching experience on self-efficacy. There is a significant effects of school location on self-efficacy. Collectively, this is multivariate. Teaching experience and school location. Okay, teaching experience and school location collectively influences or have significant effect on the self-efficacy of the teachers. Do you understand?
Yes, yes, yes.
Right. So this is multivariate test. So now we got the multivariate. Now multivariate just showing you the overall effect. Teaching experience, overall. School location, overall. Teaching experience together with school location, overall. But which part of the subscale of self-efficacy is significant, we do not know. That one we need to go for the between effect. So between effect is the univariate finding. Okay, this is within, this is multivariate finding. Okay, this is within effect. This is between effect. Between subject is the univariate finding. So now we go, okay, now you see the teaching experience. Now we can see IS, CM, SE, CI, OE. Then we can see here, teaching experience significantly affects the instructional efficacy. Significant. Teaching experience significantly affects the classroom management. Significant. Teaching experience significantly affects the student engagement. Significant. Ini apa ni dah lupa. Open-endedness is significant. Okay, so these are the 5 subscale of efficacy. So this one you can see separately whether they are significant. That's why we can call it test of between subject, univariate. Okay, this is actually the ANOVA finding. Now you see here, this one teaching experience, Wicks lambda, significant. Is the overall finding. But when we go here, we can find it according to each subscale, univariate finding. Okay, same thing. School location, you have 5 subscale. Then you see all the 5 subscales are significant. Then you go into the teaching experience years and collectively together on the 5 subscale, you can see, okay, 0.0 significant, 0.024, so less than 0.05. All these are significant. Okay, do you understand what I'm saying? So
Yes, Dr. Mages.
yeah. If it is one-way MANOVA, you won't get this finding. So if you won't get this finding if it's one-way MANOVA, because now you will only get teacher's experience and school location, because now we are joining the two IVs, teaching years and school location, we are getting this finding. Same thing, you won't get this finding if it's one way. You will just stop here, teaching experience or school location, because this is one level, this is another level. But since we are looking into together, both together, two-way MANOVA, we are getting the interaction effect. Same. So what I want to say is this is the multivariate effect collectively. This is the univariate effect where you can go into each subscale. Okay. So I took this exactly from SPSS data. So this paper is under review. Once I can publish, then hopefully it will be published, then I can share with you. Right. So now we already know what is the multivariate combination effect, what is the univariate, the more specific effects on the subscale level. Okay, right. But then you do not know which, like, we have categorical data for teachers' years of experience. We have 1 to 5 years, we have 6 to 10, and then so on. And then we have rural urban, 2 category. So combination of which category of teachers' experience and the urban affects the self-efficacy, creates the significant effects on self-efficacy. That means we need to follow with a post-hoc analysis. Okay, post-hoc analysis. Those are many ways of doing post-hoc analysis. So now what we did is a Brofroni post-hoc analysis. So now you can see go deeper. So IS 1 to 5 years, IS 6 to 5 years. This is more on what you call that, descriptive analysis. I'm not going to show you this. Yeah, I'm going to show you this. So hold on. I think there's an error here. I think I labeled this incorrectly. Actually, by right here it should be school, location of school. Okay, this should be location of school. I think I did an error. It should be location of school. So that means the IS, teaching experience, location of school, you can see whether it's significant or not significant. CM, teaching experience, location of school, then you can see whether it's significant or not significant. So this is called Brofroni post hoc. It's not Brofroni post hoc, it's a post hoc examination, but you're using a Brofroni test. Like in the earlier ANOVA, I mentioned the key post hoc test last week. But now we are using Brofroni post hoc test because our alpha level, our dependent variable is more than one. We have many dependent variables, so that's the reason we use for Brofroni post hoc test. So this is actually checking into go deeper. IS with the years of teaching experience. This one must be. Let me see. It should be. It should be. Yeah. Location. I don't know why it's running off. Okay. Okay. So Now you can see it's this data is incorrect already. So by right, it should be location of school and then teaching experience. In combination, what you get. Okay, so this is multivariate analysis. Any question on this? Oh, well, let me check. Oh yeah. Okay. So I think I've done with one-way and two-way maneuver. Any question on this? I can share the data, all this with you later. Then you can actually go through how the analysis is done. Any question?
Dr. Mages, yes.
Yeah.
Please, I'd like to ask, out of curiosity, when you published this data, do you include all the tables from SPSS into the article manuscript, or you select some important data only?
Oh, we don't include the entire tables from here, but we interpret the finding and we write it. We interpret and then we write it according to our understanding. But the data from here is there. Like for box M, I write what is the meaning of box M.
So not all the tables are in the paper? No.
Okay. Definitely no. Because we also have to look at, like for example, if I want to present the frequency, or the mean values and all that, we cannot simply copy this and paste it in our paper. We have to look into the APA style of presenting the finding, So MANOVA, there is a way of presenting finding. So you get the finding at one point and then you need to present that accordingly, properly.
Okay. Thank you, Dr. Mages.
Okay. Right. Like for example, for box M and living test, we don't actually present the table that I showed you. We actually get the finding, we take the mean, the probability value, and then we just say whether it's significant or not significant. Living test also same thing. I'll share. I think remember the Dr. Susie, the first paper that I shared on STEM. I think after the first lecture, I shared with you the STEM paper published in SERP, Chemistry Education. So that paper actually I use one-way maneuver. So you can actually share that paper with your students as well. Yeah. So you can see how the one-way maneuver is reported. In that paper, in the STEM paper, actually when I got back the review, the reviewer was so happy with the analysis. They were so they were agreeing with the assumption. They said meeting assumption for MANOVA is one of the important criteria before you run the MANOVA. So usually what happens, people do not write how they meet the assumption. But in that paper, I wrote very detailed in how I met the assumptions. And the reviewer actually gave a positive remarks for that part of the writing. So you can actually refer to the STEM paper. And also I will share another paper on, I think, gender and grade level with the attitude towards chemistry. That also, that uses two-way MANOVA. So it will give you a picture on how to present the data. Okay, right. I think I'm done with one-way and two-way MANOVAs. I hope you can follow. Okay, right. Let me stop sharing and go back to the PowerPoint again. Right. Okay. Okay, so I touched on repeated measure MANOVA here. So you can see my PowerPoint slide, right?
Yes, doctor.
Okay, so I actually touched on repeated measure MANOVA, but I'm not sure whether I will have the time to go through repeated measure MANOVA. But if I have time, I will come back and I give you a detailed illustration how to go about it. But I would like to touch on MANCOVA because this is the analysis where we usually use in chemistry or any science education or any educational context compared to repeated measure. I'm not saying that we don't use, but my experience, we use more of MANOVA than repeated measure. Okay, so let's see the MANCOVA in detail first. How you can do it in your research later, because many of your questions that you send to me, I think you can use MANCOVA rather than using a simple ANOVA or ANCOVA. Okay, like so now I want to give you an example. MANOVA is exactly same like ANCOVA. It's an extension of ANCOVA, covariate analysis of covariance, right? So you have a covariate. So now we have MANCOVA. MANCOVA is multivariate analysis of covariance. So we have to control the covariance. Okay. So now I give you one good example, which my student have done. Is actually all these are my students' work, so I can share with you, right? So the treatment, we have experimental and control. Got two groups. Always remember, MANCOVA is best done when you have two groups. You can do another context, but in my case, I always feel like it's good to have it in treatment and experimental group. The measures is, I want to measure students' misconception on climate change, right? So misconception on climate change got 4 levels. So the DVs is 4 level. Greenhouse effect, global warming, ozone layer depletion, acid rain. The treatment IV got two groups, two categorical data. Experimental is one category, control is another category. It's not two DVs, like years of experience and location of school is two DVs. You know, that's why we did two-way MANOVA. But here, two IVs. So here we are having one IV but two categorical. So category 1 is experimental, category 2 is control. Okay, right. So the DVs, we are having 1, 2, 3, 4, 4 DVs. Right. Now, so I want to measure. So this is how we should write the research question. Is there any significant difference in the linear combination of post-test misconception mean between control and experimental group? Oh, okay. So hold on. Because it's too many slides, sometimes I do mistake. Is there any significant linear post-test misconceptions? Okay, now, so is there any significant difference in linear combination of post-test misconception mean score between control and experimental groups after controlling the pre-test score? So now you need to understand. You see, the difference between MANOVA and MANCOVA. As I said, in MANCOVA, we are controlling the covariate, right? We are controlling the covariates. So in the study I've done, the pre-tests are the covariates. So I have this word controlling, after controlling the pre-test scores, after controlling the pre-test score. So that means each level of analysis, I control the pre-test scores. Let's say it's just a MANOVA. It's not what you call that, it's not I'm not controlling. I no need to have this sentence. I can just stop here. Is there any significant difference between control and post-test means? That's it. Because I'm doing Mankova, I'm controlling the pre-test score, so I have to add this word. So if you look here, greenhouse effect, global warming, ozone layer depletion, acid rain, all these are 4 different level of DVs. You're all following me, I assume you're all following me. So 4 different levels of DVs. So I'm doing one analysis here, one analysis here, one analysis here, and one analysis here. But the overall, is there any significant difference in linear combination? This is the key word here, linear combination. So in this is a big question. So just now I showed you multivariate finding, and then I showed you univariate finding, right?
Yes.
Yeah. So for this part, I use the multivariate finding to answer the question. The multivariate within subject finding to answer the question. For this part, I will be using univariate finding for each and every one to answer the question. Okay, I'll show you the example. So what I want to highlight here is linear combination. This is a key word for MANOVA and MANCOVA. So this is the multivariate question. This is the univariate question. Okay, now, so before conducting the analysis, first I check, as usual, we need to report the descriptive finding. So this is the descriptive finding. Now, remember, this is my students' work. So one group is ICCWL. So this one, this is a climate change using web. This is the control group. So remember, this is the experimental group. This is the control group. So she had 63 students for the experimental group, control group 60 students. So she got the mean of 1.93 in the pre, and the total item is only 13. Okay, we got the questionnaire from somebody else, so the total item is only 13. So you can see the mean, differences, standard deviation. This is for the overall combination of 13 items. Then here we report the for each scale: global warming, greenhouse effect, ozone layer, acid rain. So what is the pre-test, what is the standard deviation, post-test, and so on for each one. So we have for the control group and we have for the experimental group. Okay, so this is basically a descriptive statistic. Now, after giving the descriptive statistic, we checked the assumption. The first assumption is box M. So box M 0.392. So it is more than 0.05. So we can reject the hypothesis there is significant differences between the significance variance differences. So actually the variances are equal. Says there's no significant difference. So the variances are equal. Okay, so first assumption is met. Right. My second one is leave-in test. So leave-in test, we go into each subscale. So we can see that the global warming is 0.6, greenhouse effect 0.026, acid rain 0.032, and ozone layer is 0.192. So if you see here, this is okay. The variances are equal. Acid rain, okay. Ozone layer, okay. But then for the greenhouse effect, you will realize that we got it with 0.026. It's not okay. It is significant. Are you with me? Can you follow? It should be more than 0.05 to say the variances are equal. So for greenhouse effect, the variances are not equal. Okay. So what we can do is, there are few things that we can do. We can do the correction for this. So correction for this, later I will show you how we can correct it with greenhouse gaser. There's many way of correcting this. So what you call that, the analysis itself will suggest that how to correct it. I'll show you how to correct it. But literature also says that since the other variables, the variances are equal, only one you are not getting it, like the variances are not equal, you can ignore it because it's only one according to Hare. But let's say you are getting 2 or 3 where the variances are not equal, then you really have to check the data. But in this case, only one. So either we can ignore it or later we do the correction with greenhouse gaser or whatever the suggested correction. Okay, right. Now, so once we check the box M, leave-in test, then we check the normality. So normalities here, the student used kurtosis and kurtosis value. So she checked the normality and she checked whether the values are between 2.730 and positive 1.542. So if you see, the values are between the range, within the range. Then we check the multicollinearity. Okay, now I hope you are with me. So we checked the box M, we checked the leave-in test, we checked the normality. Now we need to check the multicollinearity. Right? Still remember? Now in this case, this will be a bit different than Manova. Now we are doing Manova. Okay, so you need to ensure that the relationship between covariate and DV. Okay, covariate and DV. So the covariate is pre-test and your DV is the post-test course. Okay, covariate is the pre-test, the DV is the post-test course. So there is a linear relationship between covariate, which is the pre-test, and the DV, which is the post-test. So when the relationship is linear, you are meeting the assumption. Okay, so this is also, you can get it from the SPSS. Now, so this is for the overall pre-test and post-test. So the relationship is linear. So you reject the hypothesis saying there is no non-linear relationship. Then you go into each group, the relationship of each group. So pre-test, also again, pre-global warming, pre-greenhouse effect, pre-ozone layer depletion, pre-acid rain. Then you check the relationship. So here also you will get there is the relationships are linear. Okay, so there is no interaction between the pre-test and the group. Okay, so there is no interaction between the pre-test and the group. That means the pre-test does not interfere with the group. So you will get the significance are like, you see here 0.4, 0.4, 0.7, 0.5, 0.6. So it shows that there is no interaction between the group and pre-test. So you control the covariate. The covariates are in control. So if you get there is a significant interaction, that means the finding that you get most probably is not because of your treatment, but probably the pre-test would have caused the changes in the finding. So here we see the significant 0.4 or not significant. So the pre-test does not affect the group. Can you all understand? These two I didn't mention in the MANOVA. MANOVA, we just check the multicollinearity. But now in the MANCOVA, we are checking the relationship between covariate and DV. So we must make sure the relationship between covariate and DV is linear. Okay, then we check the interaction effect or the relationship between the groups and the pretest. So now you have two groups, right? Control and experiment. And then we check the interaction effect between the group and the pretest. So for each global warming, greenhouse effect, ozone layer, acid rain. So we see here all non-significant. So this shows that there is no interaction between the group and pretest. Can you all understand? So now we check all the assumptions ready. So after checking the assumptions, now we will go into the multivariate finding. So multivariate finding, it shows we refer to Wicks lambda. There are many findings will come out, but then we refer to the Wicks lambda. Then we can say that there is no any significant difference in the linear combination of post-test misconception means cause between control and experimental group. So this is the hypothesis that I showed just now. So what we can see is you look at the group here. Okay, the group. So you have two groups, experimental and control, and then you see the significance is 0, 0, 0. So it shows that there's no significant effect of combination. Remember the first research question on the multivariate? Now this is the question. Is there any significant linear combination of post-test misconception mean scores between control and experiment? So the word linear combination. Okay, right. So here we are looking at the multivariate findings. So just now I showed you in the word file, right, how SPSS finding will appear. Exactly. So I'm not using all that finding in reporting. I just use APA style to cut and paste, present it according to APA style. So just cut and paste the finding that I want. So when I look at the group, control and experiment, I'm getting 0, 0, 0. That means there is no any significant difference in the linear combination. I can reject this hypothesis because I'm getting 0, 0, 0. There is significant difference between control and experimental group. Okay, so the effect size is 0.781. This is something wrong here. Okay, 0.781. So 78.1% of the changes in the group differences is explained by the treatment. Okay, 78.1% of the group differences is explained by the treatment. So it says that the treatment is quite effective in bringing the changes. So this is for the univariate. Multivariate, the overall. That's why we reject the linear combination. Until here, okay? Right? Now, once I got the univariate finding, now I'm going to go into multivariate. So multivariate, I just go look into the group here. It's too small for you to see, but I'm not sure how to actually show this to you. So for the group, I have post greenhouse effect, global warming, greenhouse effect, ozone layer, acid rain. So all these things I got it as 0, 0, 0, 0. So this is the univariate finding. So I can reject the hypothesis there's no significant difference for global warming, greenhouse effect, ozone layer, AR, acid rain. So all these are non-significant, and I can see the effect size 58.7, 41.3, 24.0, 43.8. Okay, so in one way running of Markova, I can measure the effectiveness of the treatment on reducing the misconception overall and also reducing the misconception on each subscale: global warming, greenhouse effect, ozone layer, then acid rain. Can you all understand up to here?
Yes, 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 yes.
Yeah. So this is Mankova. So if you see Mankova, Manova, two-way, one-way, it's almost the same. Mankova, you just have to control the covariate. So in the experimental design, it is a pre-test, post-test. It is covariate is pre-test. So I showed you just now how to control the pre-test. You know, so that's how we run the what do you call Mankova. Okay, Dr. Susie and Dr. Hernani, up to here, I have completed Mankova and Manova. I have one more, which is repeated measure Manova. Now, if I go to that, I cannot touch the exploratory factor analysis. It will take time as well. So shall I go to exploratory factor analysis, or I go to the repeated measure Manova? Which one you want?
Bu Hernani, apakah lebih baik ke repeated measure Mankova atau faktor analisis? Kalau saya pribadi lebih baik faktor analisis sebetulnya ya, agar ada bayangan.
If you want
Bu
me
Hernani kayaknya masih mute ya. Assalamualaikum Bu Hernani. Ya.
Ya. Di kita jarang digunakan Mankova ini karena ini yang variabel kontrolnya itu masih banyak yang belum teridentifikasi gitu ya Bu Tusi ya.
Jadi mungkin bisa masuk ke faktor analisis ya Bu?
Iya betul. Kita biasanya langsung ke faktor analisis gitu.
Okay, right. Okay, thank you, Dr. Susie and Dr. Hernani. So I've done with Manova, Mankova. So now we shall look into the factor analysis. Okay, so factor analysis ini ada dua. Okay, there are two types of factor analysis. One is exploratory factor analysis. Another one is confirmatory factor analysis. So I will try to touch these two as much as possible, so you can get an idea of what is exploratory and what is confirmatory. Now, in statistic, like usual chemistry research or science education research, we will try to get we will use instrument to measure the our DVs, correct? We will get instrument to measure our DVs. So for attitude, we have a questionnaire from Chung. For motivation, we have a questionnaire from there are many questionnaires. We have motivation towards learning science questionnaire. Then we have also NEP, new ecological paradigm instrument measure belief or attitude. So what we do is, normally when we want to conduct a research, we will just simply take the questionnaire and then we use it in our study. So since the questionnaires are mostly from European countries or Western countries, we just do some piloting. We check on the construct validity, content validity, face validity, and all that. We give language in terms, you translate the questionnaire into Bahasa Indonesia, then you have to check whether it's valid or not, the meanings and all that. So that's more on the validity part. Factor analysis is involved when you take the questionnaire from different sources. So let's say I want to measure students' attitude towards chemistry. Rather than using Chung's questionnaire, which is already established questionnaire, I don't have any problem in using questionnaire, but I just want to explore using more questionnaire, because Chung's questionnaire only have 4 constructs. But I'm thinking maybe I need more constructs. Maybe I need more constructs on different aspect of chemistry learning. So I will go and look for other questionnaires. So let's say for the attitude, I have identified about 5 questionnaires. 5 questionnaires. So I'm taking all the items from these 5 questionnaires and I'm going to use it in my study. So since the items are from different questionnaires, you need to do factor analysis. Okay, you need to do factor analysis. You need to explore whether the items are appropriate for your context, whether the items are parallel with the factor. Now, you must understand the meaning between factor and item. Okay, so item is item. Item is like you have 15 items in a questionnaire, that are the items. So the items are grouped into construct, right? So 1 to 3 is construct 1, 1 to 4 to 5 or 6 is another construct. So these constructs are called factor in factor analysis. Okay, so now when you take the instrument from different sources of 5, 6 instruments and you want to use it in your study, you need to do factor analysis. Firstly, you need to determine whether the items are valid, single items. So let's say you take 5 questionnaires, each questionnaire got about 20 items. So 5 questionnaire, you have 100 items. So you want to measure attitude. I'm thinking it's quite impossible for your respondent to respond to 100 items. We don't want to do that, correct? So we want to reduce. We want to just use the item which is with highest reliability. We want to use the items with really measures what we want to measure, higher loading. So we want to reduce the items. So in how you're going to reduce the item, it's not that, okay, this item I feel good, I take. This item I don't feel good. You don't do like that. You need to do factor analysis. So if your item, the instrument is only from one instrument, factor analysis is not required. Factor analysis is required when you have many, you are referring to many instruments. Okay, for that purpose first. Second purpose is, you don't have an instrument. You don't have an instrument at all. You want to develop your own instrument. Okay, you want to have your own instrument. So what you need to do is, the first thing is, you do some qualitative interview. Okay, you interview people to get some finding, and from that finding, you come up with your own items. Okay, that is one way. Or you refer to some other past studies, you refer to many past studies, and you also come up with your own items. So now you have your items ready. You want to check whether the items are appropriate and whether the items can be grouped into certain factors. Because once you come up with your own instrument, you don't have your construct yet. You don't have your construct like Chung got 4 construct. Attitude to laboratory, attitude to theory, behavioral, evaluatively, he got 4 construct. But in your case, you don't have construct, you have only 20 items. You want to test whether it drops into which construct. So factor analysis is necessary when you want to design your own instrument, or you are referring to many instruments before you conduct your study. Factor analysis itself can stand as one study. It can be a single PhD or master's research, factor analysis alone. So I'm trying to cover everything within half an hour. So you can imagine I will go very fast then. Right. So, yeah. So when you say you are checking the item, and also you want to make sure that the grouping of the items are according to the construct. Okay, so that's why when I have listed the purpose firstly, to reduce the number of variables. So if you have 100 items from the 5 or 6 questionnaire, you want to reduce, you just select the most appropriate, examine the structure or relationship. So that means if two variables have high correlation, you will group them together. The factoring, so you don't know the construct now, right? So when your questionnaire is very open, you have 20 items, you don't know how the construct, which item falls under which construct. So you determine the relationship or structure, then you can know which construct it follows. Okay. Detection of unidimensionality. So normally when it is unidimensional, single dimensional, we will try not to include it. We only will include where the items can be grouped together. Okay. So evaluate the construct validity. So I'll show you how to evaluate development of simple analysis, multicollinearity again, develop a theoretical construct, approve or disapprove theories. Okay. So when you use 5 or 6 instrument, now you want to make sure the instruments are according to the theory. Or when you use 5 or 6, you feel like, okay, when in Indonesian context, it seems like it's not according to the theory which is reported in the literature, but it looks like something else. So for example, Chung said 4. Right? Chung said 4. According to theory, there is 4 subscale. But then when you take this instrument, you apply in Indonesian context, you're getting 5 subscale. So you are disapproving a theory, you're coming up with a new theory. Understand? So that's what I'm saying. So there are many things. Like the other day, I did a study with a TPAC. You know TPAC? Technological, pedagogical, content, knowledge.
Yeah. I know.
So it is a very established questionnaire by Misra, so there are many studies have done and all that. So I am doing a research on augmented reality in chemistry education. So we tried to use that questionnaire and we measured how the teachers TPAC level, Then when we did the factor analysis, if I remember very well, there is 5 construct, but in our study, we are only getting 4 construct. The technological knowledge, technological, pedagogical, content knowledge. So technological and pedagogical knowledge merge. They are not separated, they are merged. So we got a new theory which is against contradicting what is Misra's suggestion. Then we cannot simply say like that. We also need to write, we need to argue why we think it is such. So this is the reason why we need to do exploratory factor analysis. Okay, right. So I will give you some examples on what we're going to do and all that. Right. Now I give you one of my students' example. So my student, he did a study on executive function of the brain for learning physics concept. Okay. So he want to measure how the students' executive function skills in the brain operates while student learning physics. Okay. So we want to measure how students' executive function skill operates when they learn physics. So in order for us to measure the executive function, we need to have instrument. But all these 4 the instruments available in the literature, there's something called brief 2. This is another instrument, this ESQ and goal setting questionnaire. These are all the questionnaires available in the literature. But these questionnaires are very focused on these students from different countries. As you know, you want to talk about function of the brain, we feel like we need to have an instrument which is focused on the local context. We cannot simply take instrument from other people and then we conduct. Like we want to measure attitude on chemistry, no problem. Chung's questionnaire is good enough already. We have motivation, Ryan and Daisy's definition is good enough already. But this one is executive function of the brain. So when you want to measure executive function of the brain, simply taking a questionnaire used in UK or US, I think it's not appropriate. We need to have something more localized. So what we did, we take all the items from this questionnaire. Okay, so in total, we got about 70 something items. So these are the items. So goal setting. So when we combine all the 4 questionnaires, we had 13 skills. Executive function, 13 skills. Goal setting, planning, organization, shift, time management. Sorry, I always forget to. Goal setting, planning, organization, shift. So there are 13 skills or 13 construct that we have extracted from the 4 questionnaire. So we can see the item number from which questionnaire. Can you follow up to here? Right.
Yes.
So, right. So now we cannot use all the 70 plus items. I think 77 or 75, something like that. So we need to explore. We want to find out whether we are going to retain all the items or are we going to drop something. We want to know the 17 skills, 17 construct that we have identified here is appropriate, or we might think goal setting and planning we can merge, or we feel like goal setting must separate goal setting 1, goal setting 2. We don't know. So these are our thinking, our thoughts when we got the questionnaire. Okay, so what we did, we collected data. We administer the 77 items, the first round of the data collection. Okay, so before going into the detail, I would like to say that 5 steps involved in exploratory factor analysis. So the first step is the data suitable for factor analysis. So many researchers have suggested different different sample size or different number of data. So for us, we are sticking to hair. So I will tell you the reason why later. How will the factors extracted? So factor analysis, there is principal component analysis, and there is also component factor analysis. There's 2 different types of analysis. So which one you want to use? What criteria will assist you in determining the factor extraction? So normally we will set the eigenvalue as more than 1. So when we get the values more than 1, the number of values more than 1 shows the number of factors. I will share with you later. Selection of rotation of method. What kind of selection or rotation you're going to use? Are you going to use orthogonal or what? Interpretation and labeling. So when you get the groups, how are you going to label? Okay, so this is 5 steps. I will go detail on each step. Right now, so this is the items that we have gotten from the 5 or 4 instrument. So in total, there are about 77 items. Okay, so what we did, we collected data. So we collected data. We collected 330 samples. Okay, so is the data suitable for data analysis, factor analysis? You need to respond to 2 criteria here. One is sample size. Another one is KMO measure of sampling adequacy and Bartlett's test of sphericity. So you need to do these 2 measures in order to say whether your data is suitable or not suitable for factor analysis. The first thing is sample size. So our sample size is 330 samples. Okay, so according to Hare, a preferable sample size is 100 or larger, or minimum of having at least 5 times as many observation as the number of variables to be analyzed. Okay, so our reason is we are having more than 100. So we are following Hare. So our sample size is 330. So it is suffice. Okay. Another one is we are having 70 items. There were 62 items out of 70 items in the pilot study. So following the rule of thumb, we need to have 330 observation, but our observation now is 330. We need to have 310 observation, but now we are having 330 observation, so it is appropriate. So we follow Hess definition. When we run the Ballot test of sphericity, our value is less than 0.01. So we meet the Ballot test of sphericity. Then our initial MS value using the KMO index is 0.84. If the value is more than 0.50, it is acceptable. So our value is 0.84. So it shows that our sample is, our data is appropriate for factor analysis. So what you need to check is, one is sample size, another one is KMO measure, another one is Ballot test of sphericity. So Ballot test of sphericity is actually a chi-square result. We are getting less than 0.01, so it meets. Another one is KMO. The index is 0.84. It should be more than 0.550. So it meets again, right? So I can show you the detail, all the items. I only show some of the items here because the list is very long. So all the items, you can see the value is more than 0.5. Oops. Okay, 0.5. So it meets the KMO value, right? Now, so after checking whether the sample is appropriate or not, now you go into the factor analysis. As I said, there's two types of factor analysis. That's in the exploratory factor analysis, you can choose component factor analysis. In this case, we choose component factor analysis. Okay, right. So the reason for doing factor analysis is we want to find out if there is any overlap, or we call it cross-loading between the items. Okay, overlap or cross-loading between the items. So we have about 70 items. We want to know whether there is any overlaps. So from our analysis, we only find out there is only one cross-loading items. So when there is a cross-loading items, we will remove that item. Okay, so what is the reason for you to do the component factor analysis? The first step is checking whether it's appropriate. The next step is the component factor analysis. Why you need to do the component analysis? Got two reasons. One is to check for cross-loading, because we have 70 items. We want to make sure there is no overlap between the items. But when we checked, there's only one item cross-loads. So we remove that item. Okay. Secondly, we checked with the items with commonalities value. So the items with the commonalities value less than 0.4, we deleted. So we can see here, there are few items with the value less than 0.4. So the items with less than 0.4, we have to delete the item. Okay, so this is component factor. The next step in the analysis, which is finding commonalities and also removing cross-loadings. So anything which is less than 0.4, we have to remove. Okay, so that is the next step. The following step is, right, now after we remove all the items, we do the analysis again. We rerun the analysis again. From the analysis, we set the eigenvalue more than one. That means how to say, okay, like in this case, okay, So how will the factors be extracted? So we use component factor analysis to extract the data. Then what criteria will assist you in determining the factor analysis, factor extraction? So the criteria that we set is eigenvalue equals to 1. So why I'm setting the eigenvalue as 1? Because literature says when you set the eigenvalue as 1, you get the number of factors. When the values are 1 and more, that actually shows the number of factors. Okay, when the eigenvalue is 1 and more, that actually says the number of factors. So following literature, I set the eigenvalue as 1. So from when I set the eigenvalue as 1 and we run the factor analysis, we got 13 factors. You see, the 13 factors, this is the eigenvalue. So the 13 factors, these 13 factors are equal or similar to the 13 factors that we got from the original 4 instruments. Are you getting what I'm saying?
Yes.
Okay, so these 13 factors are similar to the 13 factors that we got it from the original instrument. Okay, let me repeat again. So you decide the sample whether it is appropriate to do the factor analysis or not. So you use the sample size, KMO, and Bartlett test of sphericity. After that, you choose whether you're going to use component factor analysis or principal factor analysis. We use component factor analysis because we are based on the questionnaire which is already existing. Okay, then after that we check the cross loading. We got one item which is cross load, we remove that. We don't want item which is cross loading. And then we check the commonalities. When we check the commonalities, anything the value lower than 0.4 we remove. Why we use 0.4? Because according to Hare, we stick to Hare's work. So anything less than 0.4, we ask to remove. So we realize there is 4 or 5 items with 0.4, we remove that. Okay, so after that, we run the analysis. We realize that after removing the cross loading, after removing the lower than items is lower than 0.4 commonalities, we got the rest of the items. We set eigenvalue as 1. We got the finding as the remaining items are loaded into 13 factors. Okay, these 13 factors are proportional to the 13 factors that we identify in the instrument. But we are not sure. You see that 13 factors, we have the items, correct? But we are not sure whether this factor 1 and the items in this factor 1 and the items in the original, it match or not. That one we don't know. We have to do the next analysis. Until here, we know it is 13 factor. And we see the total variance is 64.9%. So 60.49% is above the satisfactory level of 60. That means the variances among the 13 groups of factors are similar. So Hare said more than 60% is good enough already. So what we got is 68.94%. So the 13 factors are acceptable. You know, we need to justify whether why we are saying 13 factor is acceptable, because our variance is 68.94, but Hare said above 60 it is satisfactory level. Of course, you get 80, 90, that's good, but it's quite impossible to get that. You know, so we know the items are grouped into 13 factors, but then we don't know what are these factors. And we don't know what are the items in these factors, whether they are the same as the original version. So what we did is we did the rotation. So when you do the rotation, you will get something like this. Can I shift to Word file? I can show a detailed one. Hold on.
So Dr. Mages, by knowing that we had new factors from the original one, it's already one finding, yeah, Dr. Mages, yeah. Before we come up with the result of each factor itself.
Say again, Dr. Suzy, I didn't get your.
Yeah, if we have a research factor analysis, and we come up with the result that okay, we got new factor we got new factor.
Yes, new factors. Yeah.
Or we got the similar factor as the previous one. It's already one finding, yeah.
Yes, that's why I said
Yeah.
EFA, CFA can stand as one thesis.
Yeah.
You know.
Yeah. Although we haven't go through the explanation about the result of each subscale.
How shall I say that? Hold on, let me get my.
yeah.
Because it's so many. I open many things. I cannot. I want to open this, so hold on. This is Bala. No, I don't want to share this. This is not the one. Okay, never mind. Okay. Oh. Subs. Can you see the file? MSA. Okay. Yeah. Your question, Dr. Suzy, just now.
The question?
Yeah. You asked me something.
Yeah.
Yeah, you can ask. Yeah, what was the question?
Yeah, my question is. Yeah, my question is. If we conduct the research about factor analysis and we use the instrument that already made by another researcher, then we measure the factor analysis, then we find out that okay, the factor are the same, or we got the similar number with the previous one. It's already one finding of that research.
Yes.
We can go through the data to explore more about the result of each factor.
Yeah. So that's why, as I said, it can EFA, CFA can stand by itself. It's one study, and based on that finding of the instrument and the loading that you get, you can do your follow-up study. That's one thing. And most of the time, what we do is we put this as a pilot study. You're piloting the instrument to get to know more details about the instrument, and after that, you're going to use it in the real study.
Okay. Yeah.
Okay. So the factors that you get can be the same as the literature, the theory, or it can be different. The loading it gets may be different, and you can justify it. Then you continue using it in your study. You know. So normally I do EFA or CFA when I get items for many instruments. If it's just for single instrument, I don't waste my time doing EFA or CFA. I just go straight to the study research. But if it's from many instruments, Yes, I need to know whether it is appropriate or not. Okay, and also if I don't have instrument, I want to develop one instrument, yes, I have to do EFA, CFA. Okay, so now I just show you the, so can you see this table? So in this table, I got all the items. So for the first item, okay, first construct, first group, first factor, I have 3 items. In the second factor, I have 5 items. In the third factor, I have another 3 items. And then the following factor got several items. So I can see there is 13 items. 13 factors, sorry, 13 factors. How I got these 13 factors? The 13 factors, I got it from the eigen values. So 1 to 3, which is more than 1.14. Definitely, I would have also other things, but then I didn't take into consideration. I only take into the consideration where the value of eigen is more than 1. So the variance is 68.94. So what are the items? These are the items in each group. Then what you can do is you can compare and contrast the grouping of this with the grouping of the original questionnaire. So if it is almost similar, you can give the same name. Okay, factor 1, what is the name? Then you compare to other groups as well. Do you understand what I'm saying? Okay, so so you once you get your grouping, you take this item and you compare with the original set that you got from their literature. Then you see how the items are loaded in the same manner. Is it grouped into same group or they are in different group? So if it is in the same group, you can actually try to name them together. You know, so how you can name it. So in this study, what we got is almost similar. So we followed the literature and then we name it according to what they have mentioned. Okay, so this is the final questionnaire. That, not to say final, the questionnaire that we have developed after the EFA, factor analysis. That means we removed one item because of the cross-loading. We removed 5 or 4 items because of the commonalities values less than 0.4, and then the rest of the items we did the rotation matrix, pattern matrix that we got is something like this. So now we are going to maintain these items. You understand up to here? So from the questionnaire that I got from the different part of the world, from the literature, I managed to do factor analysis, exploratory factor analysis. Then I managed to come up with a new instrument with new factors and items. The items are same like what is in the literature, but then their loading are a bit different. The grouping are a bit different. So I named the grouping according to, I also referred to the literature, and also in how we rationalize, we name the group. So now we have done with the exploratory. Okay, now this is not a final questionnaire yet. Now after we get the explore, we already explore, now we need to confirm. We only, at this stage, we only have explored. Now we need to confirm. Okay, are you with me? Right, so I'm done with exploratory analysis. Now I'm going into the confirmatory factor analysis. Now how to go to confirmatory factor analysis? Now, so now we already explore, we got the items, we got the factors, but whether the factors is appropriate or not, we need to do confirmatory factor analysis. So confirmatory, you see here, the student actually named this one as goal setting. This is emotional, working memory, you know. So all this name actually we refer to the past study and we come up with our own name. Okay, now, so once this is done, we need to do confirmatory factor analysis. Okay, now let me tell you how to go about confirmatory factor analysis. So it's difficult to switch between Word and PowerPoint Word, and it takes time. Okay, actually I have the notes in PowerPoint, but let me just go through here first, so you might be able to. Okay, confirmatory factor analysis. So now I'm taking whatever that I got from the EFA. Now I need to do CFA. Okay, so continuing from EFA, the first stage is I need to define individual construct. So what is the 13 construct? I define them. Actually, this is already done. Are you with me? So since I'm following from EFA to CFA, so the step 1 is defining individual construct. So the 13 individual construct is already defined, the earlier part. Okay. Now I'm going, the second stage of CFA is developing an overall measurement model. So I need to use the data, and then I need to do a measurement model. So there is a software, structural equation modeling software. So using AMOS, I can actually draw the model. So when I draw the model, this is how the model will appear. You see, so each factor, there is an item. Each factor, there is an item. And this is how the models are related. So first, you need to do the EFA. Second, you define the construct, explain the construct. Okay, define individual construct, explain. Then you develop an overall model. So how are you going to create the measurement model? You take the data and you put in the AMOS SEM. Then you create a model. Okay, you create a model. This is the model that I got. Okay, now I need to confirm this model. Okay, the next step is designing a study to produce empirical result. Okay, now I need to confirm the model, whether the model works or not. So in order for me to check whether the model works or not, I have to check on certain values. Okay, so you see here, based on all the expected commonalities will exceed 0.5. Okay, so the first step of checking the model is the commonalities should exceed 0.5. So if I see here my data in the table, which table? So the table is in the appendix. So for all the items, the value is above 0.5. So minimum value is 0.51, maximum value is 0.83. So it meets the first measurement, that the commonalities are above 0.5. So this is the first level. Then the second level is assessing measurement model validity. So in assessing measurement model validity, you need to check the model fit. You need to check. So this is the brief model fit. You need to check the construct validity. You need to check few things, discriminant validity, and so on. Okay, that is the fourth level. So in the fourth level, in terms of model fit, these are the things you need to check. You need to check one by one. You need to check absolute fit index. You need to check incremental fit index. You need to check parsimonies fit index. All this can take 1 day of workshop to do it. So I just giving you an overall picture how it works. Okay, so the levels in the CFA, when you do CFA, one is to explain the finding from EFA. Second is to set the model. Third is to do first stage analysis. The fourth is checking the fit of the model. Okay, the fit of the model. So in checking the fit of the model, there are many analyses. So one is absolute fit index. another one is incremental, another one is parsimony. All this you need to do separately analysis. After that, you need to check on the construct validity based on the loading. Again, you will check on the loading. And then again, after that, you need to check on the, what you call that, discriminant validity. Discriminant validity, you used to, there are many ways of checking discriminant validity. One of the popular way is using HMT ratio. Yeah, HMT ratio. So from here, you can decide how many items you want to remove and how many items you want to retain, or whether the factors are appropriate. So then you will get the final instrument. Okay. So I'm pretty sure my explanation on CFA is not so detailed, or how to say, I just give you an overall picture, but if you want me to go detail, I really need time. This can go for, as I said, 1 whole day or 2 days workshop doing CFA and EFA. Okay, so normally what I do in my research, like this student, the one I'm showing here now, this student, he did a multi-phase research, mixed method multi-phase study. So what he did, first he did a qualitative study where he collected interview data. Second, he developed the instrument. Third, he did the EFA, CFA, the part of the instrument development. Then from there, he developed teaching approach. Then he measured the effectiveness. So there are 4 stages of research in this study. So EFA, CFA, as I said, can stand as one research. Depends on how depth you are going.
Okay, yeah.
Okay, right. So I think that's all for now. So for today, I didn't talk about the repeated measure, but I feel it's also important, like people, for us, when we do curriculum-based research, when you want to measure the effectiveness of the treatment, but you don't have 2 groups, you only have 1 group, you want to do the repeatedly exposed treatment effect design, repeated measure design will be very good design. Okay, right. Okay, I think I will stop here. If I have question, I can answer. Right.
Is there any question regarding this long explanation about MANOVA, MANCOVA, as well as factor analysis?
Benar Ibu Tuzi, butuh 1 hari workshop ini mah.
Ya. Jadi
menarik sekali.
Yeah. So it means that it seems to me that we kita menemukan hal yang jarang kita lakukan gitu.
Iya benar.
We rarely did it, but actually if we would like to make a survey or a questionnaire, this is what we have to do.
Yeah.
Gitu. Jadi makanya kenapa saya I insist that Dr. Mages presents about factor analysis, karena biasanya Dr. Mages usually we define the subscale first. And then, so what kind of question that would be best fit for this subscale, something like that. So, but actually what we have to do is like we identify the questionnaire or the questions, and then
yes,
we it to the samples or to the population, and then to the participants, and then we have to check whether each item incorporated into one subscale.
It's not clear. It's not clear.
Jadi how we define the subscale atau pengelompokan atau subgroup dari questionnaire-nya itu, it depends from the factor analysis, not it depends on the subjectivity of the researchers.
Yes.
Yeah.
Right.
Let
me share.
That's the main point.
Yeah. Let me share one article with you. So actually this paper got rejected already, so I send it somewhere else, so don't bother. So this paper I submitted to International Journal of Science and Maths Education. So the title is Exploring the Factors that Explain STEM Teaching Practices of Science and Mathematics Teachers and Instrument Development. Okay, so now you see here. So this paper actually I started with qualitative. Okay, so let me go to the methodology. So this is a qualitative phase where we conduct interview. Then from the interview, we come up with a questionnaire. Okay, so when this is a raw questionnaire, whether the items are valid or not valid, we don't know. Whether the items are grouped according to apa, we don't know. So just we perform the interview, we come up with the questionnaire. Then whether the questionnaire is the items are appropriate or not, we did need to use CFA, and rather than using EFA, then CFA. But rather than using CFA, there's something more latest, that's something called CCA, composite component analysis. So I replace CFA with CCA. They are similar, but I don't want to talk about it. But EFA, by right, it also CFA followed by CFA. So there are 4 levels of study. Wow. Right? So this is the interview questions, and then from the interview analysis, I got 18 codes. A total of 18 codes were extracted and grouped into 3 main categories. So teacher's knowledge, challenges, efficacy. So these are the 3 categories. So this is the items, the codes, categories, and theme. Right? So this is the interview analysis. From the interview analysis, we developed the instrument. So I didn't put the instrument here because we want to save the instrument for our later publication. So for instrument, like I said here, like a total of 33 items were constructed to measure STEM teaching practices. So STP, the first construct 10 items, the knowledge construct contain 9 items, the third 10 items, and efficacy got 4 items. Okay, so this is our construct. So once this is okay, finalized, we did the EFA. EFA, where's the EFA finding? EFA finding should be here. I cannot find the EFA finding. EFA finding. EFA finding. So this is the EFA finding. So in factor 1, I have item 4, 7, 8, 3, 2, 1, 6, 10, 9, 5. Okay, all the loadings are here. So you will realize that the eigenvalue, I set it as 1 and factor 2. You know, so this is exactly what we got it from the EFA. So eigenvalue, the total is 12, and then the variance explained is 38. So if you see 38 is quite low. So probably this is the reason why the paper got rejected. You know, so you know, so my variance are very low. You know, okay, and then after that we did CFA, but in this case I didn't do CFA. I did CCA, another approach. So from the CCA, we also dropped some items which is not so final item I can't remember really, maybe left with 30 or something like that. CCA, we use PLS SAM rather than SAM, something like that. No, so you see the removed items were factor 1 4 items, factor 4 2 items. There are total of 23 items. Left only 23 items.
10 items. Yes.
Yeah, they reduced, but the paper got rejected. So I don't know why. You know, so much of hard work and then got rejected already. So that's how.
Yes.
Yeah.
Doctor, may I know how long does it take to complete the study? This 4 study in 1 paper. How long does it take you and a team?
For this study, I think we took about 8 months.
Wow.
8 months.
Months.
Yeah, 8 months. Because this one, if I remember very well, it's one of my master student, but not research mode. We have another mode, mixed project work.
Yeah.
Yeah,
Okay.
yeah. So
Research
that,
based. Mhm.
yeah, it's not research mode. Research mode normally take 2 years. So this one is
Okay.
like a mixed mode. We
Oh,
call it
okay.
mixed mode. Mixed mode research, 8 months.
8 months. Wow.
All right. Yeah.
Berat ibu tuh sih. Berat.
Ya, apa namanya, just like ya ini untuk membuka
Cakrawala gitu.
ya, ternyata ada hal lain yang perlu dipertimbangkan, harus dilakukan juga ketika kita mau melakukan survei. So then we have to go through this way ya, Dr. Magesia, if you want to go quantitative and survey study. So survey is not really the simplest.
Yes.
Ya, karena untuk bisa apa ya, dipertanggungjawabkan atau to make sure the credibility of our data, we have to go through this way.
Yeah.
Ini Dr. Mages aja sudah they have gone through this way. Tetap masih di reject juga.
Rejected.
Apalagi kita.
The paper is rejected here, and then I think I submitted somewhere else. No, first I submit for somewhere else. Then I made a mistake because that journal, International Journal of Educational Study, they don't publish papers on teachers. They only publish papers on students. So they returned the paper. They say no, cannot. Then I tried IJSME, but IJSME, the 3 people reviewed the paper. 2 gave a very good feedback. First 2 people gave a very good feedback. The 3rd reviewer, actually, he said it's not new. He said it's not new. So when the 3rd reviewer gives some kind of comment, the editor actually, he or she should have given another opportunity for me to at least revise the paper. But then they just reject.
Okay.
It is a valuable lesson for us, ya, Ibu Tuzi.
Yeah.
Not only doing the work, but publication is also difficult.
Yeah, it's very difficult now.
Very difficult.
Right, ya. Oke, ibu-ibu semua dan bapak-bapak, kita juga punya bapak di sini, alhamdulillah. This is, I think, this is the end of our today's session, ya, Bu Hernani. Yeah, I don't think the participants will have a question. They just like feel like
Amazing.
Amazing. There's something new and complicated, but we have to go through this way. Mudah-mudahan Bu Hernani ya, nanti kita bisa ada kesempatan untuk mengadakan pelatihan, tapi kayaknya mesti kita punya data dulu agar bisa sampai workshop ya, Bu Dr. Mages ya. If you want to conduct a workshop, we have to make sure that we ourselves have our own data.
Actually,
ini kayaknya yang mau dalam nih S3-nya nih. S3-nya dengan ini nih, statistiknya luar biasa nih.
Actually, I'm conducting a workshop on a mixed method workshop for 2 days, but that one is by USM, So it is a cost is occurs. It incurs cost, so it's not free of charge. It's for the university. They are making for them. We have something called income generation, so we have to make money for the university. So the charges are quite, I don't know, it's 200 per person for 2 days full workshop. If you're interested, if you're interested, I can ask them to give reduce the price. Maybe, I don't know, if you can give like many students interested, my 5 or 6 or 7 and something like that, then I can request for cheaper price.
if you have a flyer or
Yeah, brochure. I can share with you.
the brochure, yeah.
Yeah.
This
So the
information.
workshop is 19-20 November or something like that.
Oh,
Yeah.
Mm.
Yes. Still can prepare ourselves for that.
Yeah.
work. But yeah, actually Ibu Monica dan Bapak Ibu yang lain, kita juga di sini berkesempatan untuk mengundang Dr. Mages karena kita mendapat support dari dana Dikti ya melalui program Broadcast University. Jadi kita punya alokasi untuk mengundang Dr. Mages untuk sebagai visiting professor. Gitu, dan alhamdulillah ilmunya banyak sekali Dr. Mages. You have give us lots of your knowledge, and the most special thing is Dr. Mages have provided her own experience, her own data, her own research, so it will like boost myself actually. we cannot say that, oh, I don't like quantitative, I'm a person. No, you can't do that. Dr. Mages can do everything by herself.
Because you see, inside, actually, when I started working on my research, initially when I started, I tried to publish data on quant data using t-test, as I said, 10 years, 12 years ago. I find it very difficult to get things published. But then I see other people t-test so easy. Why we are so difficult? I always have that in my mind. Then I happened to meet the scholars of science education. You know, many scholars I met from UK, US, in all these people. I see when I talk to them, they like to use qualitative data. They're not science education. I'm not sure about other field. Science education, chemistry, mathematics, and all this, they prefer to get quality data than a quantity. Because they said, okay, when you say attitude improve, your mean is higher. But how from the mean alone we can see what kind of attitude or how the treatment caused the attitude improve and all that. So using the mean value, I cannot answer. But if I have a little bit quali, I can talk a lot about that. So that's when I started to expand. You know, I started to build on the quali part as well.
But yeah, we also need this kind of quantitative. We also cannot rely only on qualitative.
Yes, true. Especially PhD student, master students, I would suggest them to have both, because if you rely totally on quantity, then there will be a question which you cannot answer. If you rely totally on the quality, there is very high risk. Then they say you are doing it a small community or small group of people. So when you have both, it supports you in many ways.
Semangat PhD.
Iya, oke, Bu Nani ada yang ingin disampaikan?
Ya, saya tadi chat dengan Bu Tusi ini. Wah, ini kita dapat banyak banget Dr. Mages ya. Dan kita harus betul-betul belajar lagi nih.
We can write paper together. So
Okay.
So I suggest young student kimia ni kan, if you can ask one of them to do one kind of study, that will be good. So it will be a learning for you as well. So someone working on MANOWA, someone working on MANCOWA, someone working on EFA, CFA. So you get all the input. So I can help you all. Not necessary you must put my name. It's okay, but I can help you. I no problem.
Keren.
Ayo Monik, semangat.
Siap Ibu.
Iya.
Jadi nanti Monik
mungkin
yang mengajarkan lagi ke Ibu nih.
Iya, baik Ibu Henani, mungkin untuk hari ini sekian dulu ya.
Okay.
Yeah, I'm afraid Mages also have another activity after this.
Yeah, at 2:30.
Yeah. And also in Malaysia, it's already new semester begin ya.
21st.
Oh, okay, nanti correct. Oke, terima kasih semuanya.
Tadi itu ini daring juga. Bu Tusi tadi yang
daring.
ya Bu Dr. Mages?
Apa dia?
Yeah, Dr. Mages, the workshop that you've mentioned, which will be conducted on November, is already in an online session.
Oh yeah, it's online. It's online.
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 Oh.
Online.
Yeah. The course in Malaysia also still online, yeah?
Yes, yes. Most of it online, but like engineering courses and all that, they are doing blending. So it's
Okay.
only if it's necessary, then you go to the university. If not, you're like people like us in education, we not really requested to go back. We are still all
Yeah.
our lectures are still online.
Ya, itu pun untuk mahasiswa yang sudah ada di kota itu.
Yeah.
Kalau mahasiswanya belum di situ tidak boleh pindah ke
Yeah,
kota itu.
yeah. Right.
Oke, terima kasih banyak Dr. Magis.
Yeah,
Mudah
thank you so much.
bermanfaat, insya Allah bermanfaat untuk semua.
Sangat.
Kita juga jadi semakin tidak sabar untuk bertemu lagi pekan depan. Apalagi nih hal baru yang kita pelajari. Ketika kita diskusi dengan Dr. Hernani, ya, it seems like very common. Yeah, we in research method we learn about quantitative and we learn about qualitative, and then after that we learn about mixed method. But di setiap harinya kita selalu belajar hal yang baru di keseluruhan itu, dan saya harap mahasiswa pun sama ya. Dulu ketika S1 belajar research method juga ya, tapi sekarang kita di sini belajar juga banyak sekali belajar hal-hal baru tentang itu. Next week kita juga akan belajar hal yang baru dari Dr. Mages. Mudah-mudahan kita tetap sehat, tetap dan kita berjumpa lagi dalam pekan depan. See you next week. Assalamualaikum.
Okay, bye-bye. Thank you so much. Bye-bye.
Thank you very much.
Thank you.
Terima kasih, Dr. Mages.
Thank you. Bye-bye.